Hidden pressure in pipes, a live safety demonstration. Every year, workers tragically die or are permanently disabled while conducting hydrostatic testing. So we asked ourselves, why does this happen? Why are people getting hurt unnecessarily? What we found was this, that there were many reasons, and most of them were preventable. Many of these incidents occurred due to procedural circumstances, such as not following or not knowing the correct procedures for conducting piping systems testing. Some incidents occurred due to a lack of awareness of the hidden dangers associated with pressure in piping systems. Most, if not all, of these failures are catastrophic and involve high-impact incidents with either projectiles or pressure forcefully impacting workers. In some circumstances, workers are injured while inside the prescribed clearance zones. This can be attributed to a lack of management controls, to include enforcement of appropriate clearance zones. Another factor is designing systems with testing means and methods in mind, such as remotely operated gauges or valves. Many times, the pipe failure becomes much more severe due to not following other safety protocols or procedures. This can be as simple as wearing the appropriate PPE, to include fall protection when working at height. Our model is a piping network used to represent a typical pipe system with enough complexity to confuse most every person. We developed the model in order to be transportable by one person. We used PVC due to ease of construction, affordability, and being a lightweight material. Additionally, in order to show hidden dangers, we use sections of vinyl and silicon pipes. For safety purposes, we operate at no higher than 60 psi, which is a much lower operating pressure than most systems. And most importantly, we do not damage the pipe network or put any personnel at risk during testing, due to the system being completely enclosed in a plexiglass case and small action figures being used as representative models. Ideally, our model would be operated in person, with hands-on functioning of the model and goal-oriented learning experiences. For those that can't be on site with us today, we will demonstrate the model via video. If the workers operate the model successfully, when the pressure is released into the system, there will be no piping failures, and Batman survives another day. However, if the system is not appropriately isolated, then Batman will not have a very good day. These exercises are meant to be thought-provoking and simulate the complexity of piping networks in the field. So now we ask ourselves, how do we prevent this from happening in the future? By conducting hands-on training, such as reproducing and using our model, or one very much like it. Also, by conducting company-specific on-site training, specifically related to the job at hand. Additionally, enforce clearance zones as necessary, but preferably, when possible, keep workers out of the area completely by implementation of technology. This technology could be remotely operated valves or gauges to monitor and pressure test from a safe distance. We hope you've learned something in a new way today. And those of us at the University of Colorado, stay safe out there. Special thanks to ConocoPhillips, including Mr. Glenn Clement, and the University of Colorado, Professor Matt Hallowell.